So with that, let's talk about constraint satisfaction problems. So constraint satisfaction problems are problems that essentially pretty much you can apply anything you've learned up until this point, such as like for loops, while loops, pretty much all the logic that you kind of know how to solve problems, recursion, to solve constraint satisfaction problems. But constraint satisfaction problems are very specific problems in that they have three different components to constraint satisfaction problems. And the one component is a set of variables. So, all right, cool. Like we've been dealing with variables throughout pretty much all the challenges, but these variables are specific to the problem in that there's only a specific set of variables that you can use in the problem. Two is a set of domains. And a domain is essentially what are the possible values of the set of variables. So, for example, maybe a set of variables is you can only have even numbers. Okay, so or like you have, and we'll get into an example of this, but like a set of variables is you're given an array of 6 elements, but like there's nothing specifically saying what those 6 elements in the array can possibly be. Whereas the domain will say, hey, what are the possibilities of those elements in in that array or object, or just random, like a variable A, like what's the possible values of that variable A. Questions so far? If you don't know, that's okay, because we're going to show you an example. And the last thing is the main thing, is constraint satisfaction problem, is that it also needs or has a set of constraints. So the set of constraints can be anything. For example, like the variables, like the values in these variables can't be even or odd, or they can't be divisible by 3 or anything. They can't be the value can't be a string value with the value of cell phone. Like those are constraints that these problems can have. So it needs a set of constraints. There's a popular one, a given example is that you see in a lot of CS problems. For this example is like, all right, you have Australia or the United States or some land continent with countries, and you have to label those countries a specific color. So the colors can only be, so the set of variables are like all the states in the United States. And the domain, what are the possible values, are the colors of each state can only be red, green, and blue. And the constraint is no state touching another state can be the same color. That's an example of a constraint. And that's a very common, if you look up like constraint satisfaction problems in Google, a lot of that documentation is like an example of that, but with Australia. But if you think about constraints, like constraint satisfaction problems, which is a problem you're going to be solving today, is Sudoku. Like Sudoku has a set of variables, such as columns, rows, boxes. A variable, I guess that wouldn't be a variable, but a variable would be a slot in the box. So like the number can be between 1 and 9. And so that would be the domain of those variables. So a variable can only be values 1 through 9. And the set of constraints is no row can have duplicate numbers, no column can have duplicate numbers, and no set of boxes can be duplicate numbers. So those are a set of constraints for trying to solve Sudoku. All right. So let's talk about, no, did I forgot to record? Okay, no, cool. So there's a couple of ways we can solve constraint satisfaction problems. And there are a couple of strategies. A couple of main strategies is a strategy called backtracking, or essentially backtracking search, is where you see if the next value, you plug in a value of a possible set of domains to a variable. So plug in a possible value into a new variable, and then check that variable against the set of constraints. And if it passes those constraints, that part of the problem is solved, it can move on to the next variable. Whereas if it doesn't, then it just resets and checks that same variable with a different value. Another one is forward checking, whereas you, similar to kind of backtracking, you check the next variable, but then you keep track of all the forward legal values. We're not going to talk about forward, or we're not going to actually implement a forward checking because it's a little more difficult. But these are different types of ways you can solve it. So strategies. Forward checking, or I'm sorry, backtracking search, and forward checking. So let's do an example of a constraint satisfaction problem. So let's just say we're getting, so a set of variables, let's just say our variables or variable is an array of 6 zeros. So this is our variable, or variables, I guess. And our domain is going to be 1 through 9. So any variable, any value within this array can have a value of 1 through 9. So what we're going to try to do is fill out this array with values from 1 through 9. And we can increase this to like whatever, like an array of 100 or array of, 1,000, whatever we want. But for this example, we're just going to have an array of, we're going to start with an array of 6 zeros. And we're trying to fill in each value in this array with a number that's between 1 and 9. So those are the possible values that each element in the array can be. So that's what the domain is. So what are all the possible values of the set of variables? Questions so far? But now for the constraints. The constraints, this is where the main thing is, the main part of this is for these types of problems, is that we have to have at least one constraint. So the constraint of this problem is going to be even indexes have to be an even integer. So even indices must have an even integer. And the other constraint is that can't have duplicate integers in the array. So we have to somehow, we're given an input array of 6 zeros, and our output array has to be an array of 6 integers. So if this happened to be, is that 6? So does this, like, is this a possible solution? So I could implement an algorithm that does this, but would this satisfy the constraints? So index 0, 4, that's an even number. It's an odd index, so it doesn't matter what integer it is. Index 2, that's an even integer or even index, so we have an even integer there. 7 doesn't matter. So 4, index 4 has a value of 3, so that does not satisfy this constraint. So then I'd have to go back and check this value or plug in another value until it satisfies these constraints. And then I'll keep moving on. So again, our input will be an array of 6 zeros, and our output should be some array of integers that satisfies these two constraints. For example, like 4, 6, 8, 1, what else? 2, 7. So even though this is an odd index, it could still be an even index or even number, because the constraint is only the even indexes have to contain an even integer or even number. It doesn't care what type of integer that the odd indexes have, as long as there aren't repeating integers in the array. So a good way to solve this is to first, let's write a couple of methods that take in, let's write a method for each of these constraints. All right, so even indices must have even integers. So if I were to create a method that checks if an index is even and an integer is even, and if that's the case, it will return true. Otherwise, if it's an odd index, we don't really care what type of integer goes there. So checks for even index and even integer. And this will just we'll want to just return a Boolean value, true or false. So check index. What parameters should this constraint method take in? I'm calling someone. George.
Yes.
Can you hear me?
Yeah, I can hear you.
Yep. So if I'm going to write a method that checks whether an index is even, as well as if an integer is even, what 2 parameters should I pass in? What kind of methods or what kind of parameters should?
So okay, so 2 parameters here. So one's definitely gonna be the list where the integer is gonna be.
So what would that be? Like a list, what would be that value? Would it be in an index, an integer, or a list?
Um,
And it's okay if you don't know.
yeah, I'm not sure here.
Okay.
I'll take a stab at it.
Yep,
So you're
Everett?
going to need to know the variable index.
All right, so we'll need the index.
And then you're going to well, you're going to check the domain somewhere else, but I mean, would you need the domain? So it's a number between 1 and 9.
Yep. So yeah, exactly. We're going to need a number between 1 and 9. So let's just say number.
Okay.
or value or whatever. Cool. So that's all we need right now, because all we're literally going to check to see if this index is even and if this number is even. And if both of those are true, then we can return true. If this is true, if the index is even, but the number is odd, then we should return false, because even indices must have even integers. So I can just say, hey, if IDX, so if the index, how do you check if something is even? Use modulus. So index modulus 2 equals 0. That means that's checking if it's even. If that's true, then we're going to go ahead and check the number to see if that's even. And if that's even, we're going to also, then we're just going to return true. If num modulus 2 equals 0, we can just return true. Else return false. But if the index is not even, that means if it's odd, we don't care whether the integer, the number, is even or odd. So we're just going to return true at the very end. So this part is if the index is odd, the number can be either even or odd, because we don't care. So we're just going to return true, because we're going to run this check. And if this returns true, we're going to do something with that. So we just check that constraint. The next is can't have duplicate integers in the array. So def check duplicates. All right. So what argument or arguments or parameters do we need to pass in here to check if our input array has duplicate values? What do we really need?
Current array and a current value.
So we definitely need the current array. Do we need the current value? If we already have the current array, can't we just check
The whole thing.
the whole array? Yep. So let's just say current array. So now, how do we check duplicates? We can loop through that current array, keep track of values in a dictionary, and increment each value. But there's an easier way we can do that. So if this is our input array, and we're going to be changing these values in place, we only need to extract the values that are not zeros. And how can we do that? I'm going to say non-zero array. So this is going to be an array that doesn't have any zeros. And if you remember list comprehension. So I'm going to say, hey, return the number for num in current array. So return the number. So I'm looping through each number in the array, and I'm returning each number if the number does not equal 0. So this will return an array of positive integers, either from 1 through 9, that exist in the current array. So, and this is going to return a Boolean value. So checks for duplicate values in the array. And this is going to return true or false. Because if it's false, so if it does have duplicate values, then we want to go back and check a different number. So we've got non-zero array. So an array of non-zeros. And in order to check to see if this array, so for example, if it does have duplicate numbers, such as, let's just do an example. Example input. We got 2, 3, 4, 5, 5, 6, like that. So this one would have duplicate numbers, and I can even, so then this one would, since there aren't any zeros, that would be the non-zero array. So how can I immediately check to see if there's duplicates in here? There's a data type that looks like an array that does not have repeated numbers in it or repeated values in it. Even if I pushed a value into it, it would not add it.
Is that a tuple?
Not necessarily a tuple.
Dictionary can't have like more, it can't have the same key twice, right?
Yeah, you can't have the same key twice.
A set.
A set. Yep. So if you haven't heard of a set looks like an array, except it just doesn't have not repeated values in it. So here, I just can return the length of the non-zero array. Whoop. So that would be 6. And equals the length of a set. And I pass in the non-zero array. So this non-zero array, 2, 3, 4, 5, 5, 6. If I pass it into a set, the set would only be, the set output essentially would be 2, 3, 4, 5, 6. Because it doesn't have 2 5s in it. So if I compare those, the length of the non-zero array, which will have the length of 6, equals the length of a set of the non-zero array. That means it will remove the duplicates of that. So that this length is 5, this length is 6. That means it has duplicate values in it. Therefore, the length of 6 does not equal the length of 5. Therefore, this would automatically return a falsy value. If it didn't have repeated values in it, like this, the length of this set would be 6. The length of the non-zero array would also be 6. Therefore, these would equal one another. Therefore, it does not have non-repeated values in it. Therefore, this would return true.
Does that preserve the location of all the values? Is it a 1-for-1 copy of the array if you were to?
Does anybody know off the top of their heads? I think, I'm trying to think. I don't know off the top of my head.
Okay.
I think a set might be already sorted, but I don't know. I could be totally just making that up.
Okay.
But so yeah, I don't know if it retains the same values in the same index. So this checks for duplicates. So this constraint differs from this constraint a little bit. So a constraint that only relies on a single variable, such as the index, like the only thing that matters is whether or not this number is even and this index is even. So it doesn't rely on any other variables within the input. So all it cares of, for example, as long as 4 is even and as long as the value, the index where 4 is even, it's good. It doesn't, this check index does not rely on any other index, any other variable within the problem. So this is actually called a unary constraint because it only relies on a single variable. Only checks, I guess, against a single variable. There's also binary constraints, which is it checks on two different variables. And anything that has checks against three or more variables is called a higher order constraint. For example, check duplicates checks against all variables within the input array. So this would be considered a higher order constraint. So just be kind of like cognizant of, hey, what a unary constraint is, binary constraint, a higher order constraint. So this checks against three or more variables within the input, within like the variables. All right. Okay, so we've written our function, our constraint functions that tests against each constraint. Now we can actually go ahead and write our check whether or not our input variable. Yeah, so now we can actually write our function that will generate an output that meets these constraints. So I'm just going to call this CSP because constraint satisfaction problem, list creation, and def. And this list creation is going to take in just an array of 6 zeros like that. And the output is going to be something that meets these constraints. So like a value of like 3, I'm sorry, that's wrong already. 4, 3, 6, 8, 2, 9. So this meets those constraints. So yeah. Let's say input list, and the input list is going to be an array for range 6. So that's how you quickly create an array of 6 zeros. All right. So let's go ahead and try to solve this and try to fill out this. Just gonna say it. Whoop. That's gonna be example solution. So the input equals an array of 6 zeros. So input list is also, I'm describing exactly what I'm putting in, but the input list corresponds to the variables that I'm inputting. So that's the input list. I can also just call it variables. But yeah. So input list. And also I'm going to take in the current index. And the current index, I'm going to start at a default value of 0. Because what I'm going to want to do is generate a random number. So how I'm going to try to solve this is my input. I'm going to start at the current index. I'm going to randomly guess a number between 1 and 9. So that satisfies my domains. So I'm going to create a number, generate a random number between 1 and 9. Put that number in here, then run it against this check index and check for duplicates. If both of those satisfied, I'm going to keep that. And then I'm going to recursively call the input list with now 1, or what my guess number in here, and my current index to increment by 1. So my next index, I'm going to check this one. I'm going to generate a random number, fill that in, check against my constraint methods. If it satisfies it, great. I keep moving all the way down. And that's called backtracking search. That's like the method that's like the problem. That's the strategy I'm using to solve this. If I happen to get to one and like I fill in this value here and guess a random number between 1 and 9, and this happens to be 5, which doesn't meet the constraint functions. So like check index, because this is an even index, 0, 1, 2. So this number needs to be even. I'll recursively call this by not incrementing this index to the next index. So I'm just going to repeat this value, this index again, by generating another random number, filling it in, checking against the constraint methods, and just do that until I finally solve this input array or fill it out with a valid solution. So in order to do that, I'm going to create my domain variable. I'm just calling it domain just because set of variables, set of domains. So what are the possible values? It's going to be an array of 1 through 9. I could literally type 1 through 9, or yeah, I'll just do 1, 2, 3, 4, 5, 6, 7, 8, 9. I could do that, or I can do 1 through 9. And now I can say, hey, if 0 is not, if not in variables or in input list. So if there isn't a 0 in my input list, that means I've solved the solution. So I can just return the input list. So I'm going to solve this recursively. So this is my base case. Else, I'm going to guess a random number between 1 and 9. So I can say guessed equals rand int between domain. So this is my arguments. So if that's the case, I need to import from random import rand int. So that's my guess number. Now I can check against these check index and check duplicates. So the first thing I'm going to do is say, hey, if the check index, if this returns true, I'm going to pass in my, what is it? My index. So that's going to be the current index right here. Current index and my guess number. So if that returns true, then I'm going to replace my input list at the current index to equal my guess number. So this is where I'm replacing that value in my input number. Instead of 0, I'm replacing it with, say, 4. And now I'm going to increment my current index by 1. So my initial current index is 0. Now my current index, if this returns true, then I'm going to increment my current index. And then after I do that, I'm going to check against the next constraint. And I'm going to say, hey, check, if not, check duplicates. And I'm passing in the new input list with that new 4 in there. So if this returns false, so if it doesn't have duplicates, then that's great. But if it does have duplicates, that's what this is. So if not true means false, then I want to repeat this, essentially replace 4 with 0 again and rerun this CSP list creation. So if there are duplicates, that's what that's checking. I'm gonna current index. I'm decrementing the current index back down by 1, and I'm replacing my input list at that current index to equal 0 again. So I'm replacing, I changed that number, I tested against it. It didn't meet both of these criteria. So now I'm replacing it back down to 0. And then at the very end, I'm going to return the CSP list creation. So this is where the recursion comes in, where I put in my input list and my current index. So this part, if there are repeating numbers in the input list, go back and replace the index back to 0, or replace the value at the previous index back to 0. That's what this is doing. And this part is just replacing the current index value with the guest number and incrementing the current index by 1. So I'm just solving this recursively. I can check this by doing print CSP list creation. And I can just pass in a range, an array of 6 zeros. If I were to run this, if everything is done right, Python CSP, it meets the criteria. So 6, 5, so value index 0, that's an even. So we have 6, 5. So this 5 can be any integer, it can be even or odd. But again, just the even indices must be even. And I don't have repeated numbers there. If I keep running it, I'll get a different one that meets the criteria. Let's see if something happens if I. So yeah. And this is an example of CSP constraint satisfaction problems. So just a unary constraint, and higher order constraints. So just know that those are two different types of methods, constraint methods that you can write. What questions do you have?
Hey, Tom, the syntax on 46, is that's turned into a range by the syntax on 51?
Yeah, that's what
why
that's
it's not
doing.
just a list. Okay.
Yep. So yeah, that star just passes in the arguments, args. And you can easily just do like, the only reason why I did like domain 1 through 9 is like, I could have just easily done like that. And then instead of guessing a random input between there, Well, yeah, I guess I could, there's multiple ways you can just guess a random number between 1 through 9. I think you could also do like 1 through 9 or something like that, or 1 through 10. Like that as well.
Got it.
Yep. So what other questions do you have? Highly encourage you. Let me just pause the